Alright, first of all, let's just talk about what probability is. It is the likelihood that an event will occur, and it varies between impossible and for certain. Let's think about something that is impossible, that has a 0% probability. Can anybody think of an example? Yes? Do you think of something? Jumping 100 feet high. That's just right. That'd be impossible for us, right? What about something that's for certain? Well, you put the one blue, you put a small likelihood of drawing blue. But what if we had a whole bag of green marbles and we were going to draw it in green? Okay. So that's for certain. So all other probability exists between impossible and certainty. And so since this probability goes from 0 to 100, it's not, you can't really say that there's a 110% chance of so-and-so happening. It makes no sense. Because if something is 100% likely to happen, then it's for certain, and not, can't anything else happen, it's for certain. And so let's define probability as the number of successes over the total number of events, or the likelihood that an event will occur, and say that all things exist between 0% and 100%. Or if I take that out of percent form, between 0 and 1. Okay. So probability is usually expressed as a fraction, and that's why. Because 100% is 1. If something is for certain going to happen, like drawing a green marble, it's 1 out of 1. That's the only color I have. Alright. Whoops. I think that was right, actually. Okay. Let's make us a table. And let's number 1 to 20. And down through here, we'll have heads or tails. For example, if I flip my quarter and I get tails, I do this. If I get heads, I do that. Now, I want you to do it in pairs, because one person can do the flipping and the other person can do your recording, and then you can change and do the same thing for the other person. Do y'all understand? Now, when you do a flip, you got to do a fair flip. You can't just throw it up and let it come right straight back down. Nothing happened there. You are affecting the outcome. Alright, so when you flip a quarter, and let's try not to have flying quarters. But when you flip a quarter, if you flip it up, it's bobbing this around. Let's flip it up in the air and let it flip. And then let's do it just like that. Okay, so flip it up. Make it spin. No. And then catch it and put it down and make it a fair flip. Now let's try to control these and not let these going all over the room. Alright? So you're gonna flip it, catch it, and that one's heads, okay? Then you do something larger for the right. Do pairs. Somebody's recording, somebody's flipping. Each one of you will do it 20 times. Alright, so find your probability for yourself. Number of heads that came up divided by 20, and the number of tails that came up divided by 20. And then do you as a pair figure that probability. Make sure you got your calculator out. Exactly the same. Is it 50-50? It's close. It's close. It's close. Now, I've got one pair that got mostly tails, and one pair that got mostly heads, so I guess they're going to even each other out. Did you? Alright, so if you've got your calculator as a class, I want to do number of heads and number of tails. Now, how many students do we have here today? How many do y'all count? How many students do we have here today? Do y'all count 22? All right, if each person flipped 20 times, then how many flips is that? 440, right? All right, so here we go. I'm going to go around the room and point at you, and you tell me how many heads that you done. All right? And we're going to add up what they say, so keep up on your calculator. Y'all ready? Or just do it in your head if you want to. But I suggest the calculator. We're just going to do individual total. Let's just do individual total right now. All right. All right, I'm going to start right here with you ladies. All right, just call it the number of heads that you personally flipped. 11. You guys type that in. We're going to add to the next. 11 plus heads. 10, 4, 12, 14, 10, 14, 11, none? Oh, I thought you did 9. Good. All right, well, 8, 10, also 10. Okay. 10, 11, 8, 11, 11, 13, 10, 10, and 8. The total of that is? I agree. 226. All right, so 226 over 440. What would that give you as a probability? Yeah, right at 51%, 51.4. We'll just say 51%. All right, if we had 226 heads, how many tails were there? How do we find that out? There are 440 flips. So subtract that, you would get how many? 214. All right, so 214. Divided by 440. I had a mess up right there. 214 divided by 440. 49%. That's pretty close, isn't it? Now, since they are equally likely to happen, what does common sense tell you that they are 50% right, 50-50? Okay? The more that you do, the more flips you do, the more accurate the data becomes. Like one person can flip mostly tails, one person mostly heads. Somebody had 13. But when we all go together, and the more that we did, the closer that it would approach 40. Or excuse me, 50%. Sorry about that. All right, now let's look at these. If I have dice and I roll them 100 times, an even number appeared as a sum 47 times. Based on this experiment, what is the probability that 2 rolled die will show a sum that is an even number? Well, how many times did it happen? 47. How many times did we roll? 100. So that's pretty easy to figure the percent, because percent, calculators don't bounce, do you? 47%. All right. All right, if 2 number cubes were rolled 100 times and a sum greater than 8 appeared 29 times, based on the experiment, what is the probability that 2 rolled number cubes will show a sum greater than 8? Well, how many times did it happen? 29 times. How many times do we roll? Just so happen 100 times. So as a percent, that's pretty easy, right? 29%. All right, 2 coins were tossed 200 times. 2 heads appeared 48 times. What is the probability that 2 flip coins will show 2 heads? What's the percent? Yes, 24. Because it happened 48 out of 200 times. If I reduce that over 100, 24 over 100, that would give me 24% of the time. Alright, you guys try this. Do this one in your notes. 2 coins are tossed 200 times. 2 tails appeared 52 times. Based on this experiment, what is the probability of 2 flip coins showing 2 tails? Alright, so Tyler, how do you start that out? What do you put over what? Okay. If I wanted to make that into a percent, I could reduce it, or I could just do it on my calculator. Of course, but so that would be what? This would reduce to 26. So what percent would it be? 26%. That's good. Alright, we're going to, let's see. We're going to roll 2 dice and record what we come up with, okay? So let's make a table all the way to 20. And I'll roll, and you write down the sum in the table. Alright, so we're going to roll 2. And so the sum would be 3. Next, the sum would be 6. The sum is 9. Yep. The sum is 12. Alright, the sum is... Oh, what did I put? Oh, was it 2 5s? Is it 2 6? Oh, sorry. I saw 2 6s for some reason. Alright, so the sum here is 6, right? I better watch me. The sum here is, again, 6. The sum is 3. 9. 4. How many is that? I've run out of room. So you guys got to write the rest of it, okay? 6. 9. 8. We can make this really go fast. 6. Oh, we can make it go really slow. 6. What, 8? How many more do I have? Okay, this is 8. 3. 10. Have I got 2 more? Thank you. 7. And last but not least is 6. How many times was the sum greater than 8 out of 20 times? No, don't. That's a good question. Don't count 8. It's got to be greater than 8. How many times? 5? You guys agree with 5? Okay, so 5 out of 20. What percent would that be? Well, this reduces to 1/4, which is 25%. Okay, go to page 183 and 184. We're going to do 12 through 30. Now, I have some dice if you want to use those, because there is a problem, I think, you have to deal with dice. So I'll get those out for you.